In this video, we're going to build a self-driving car powered by a Raspberry Pi. I'll use the software from the fantastic Donkey Car project and adapt it to run on a much cheaper platform. I'll outline the changes that we need to make on the software and show the steps that are needed to get the Donkey Car software to drive this platform. Alright, let's do this. This video is sponsored by PCBWay. They are a PCB manufacturing and assembly house, and one thing that sets them apart is that they're not a broker. Instead, they're a fully featured PCB manufacturing and assembly house offering a wide variety of services. Those include advanced PCBs like Flex and Rigid Flex, and also assembly and design of your printed circuit boards. With friendly staff and great facilities, I highly recommend PCBWay for the design, manufacturing, and assembly of your printed circuit boards. In another video, I've gone over the steps to assemble this inexpensive robotic platform. Assuming we've done that already, I'll get started with the software side of things. As usual, you can find these components in my little Amazon shop. I'll leave a link in the description of the video. With the end goal of autonomous driving, the first step is to install the Donkey Car software on my computer. I won't be using it in this video, but later I'll make use of it to train the models that will drive the car autonomously. I'll create a directory that I'll name projects, download the Donkey Car repository using Git, and check out the master branch. The simplest way to get the Donkey Car software running is by using Anaconda. For our purposes, Anaconda includes all the tools, packages, and other things that we're going to need for running the Python software that the Donkey Car project is based on. I'll check that the installation is successful by opening a terminal window and typing in the command conda list. If I don't see any errors, I'll change directories to where the Donkey Car was downloaded and create the Python virtual environment for this project. I'll activate the virtual environment and use the Python package manager pip to install the rest of the software. Then I'll finish up the installation by using the newly installed utility donkey to create an instance of a Donkey Car that I'll call Acrobatic. With that out of the way, we can move on to installing the software that is going to allow us to drive the car around on the Raspberry Pi. Making sure that the SD card is inside the Raspberry Pi connector, I'll go ahead and connect USB power. As I've shown in another video, I configured the SD card to allow for remote management right off the bat. I'll use the terminal window on my Mac operating system to establish an SSH connection. The first step is to use the Raspberry config system menu to enable the camera, which in my case is optional as I'm using a USB webcam. Then enabling the I2C interface so that we can control the motors, and finishing up with expanding the file system. With these changes in place, we'll allow the Raspbian operating system to reboot, and after it does so, I'll SSH back in. With the Raspberry Pi configure, we can move on to installing the Donkey Car software. We'll first need to install a few dependencies to the operating system. I'll simply copy-paste them from the project website. I'll leave a link in the description of the video. As I'm planning on using the fantastic package Opencv, I'll install a few additional dependencies. With that out of the way, we need to follow the same procedure that we did on our computers. But as we already have the tools built into Raspbian, we won't need to install anything like Anaconda. I'll simply use Python 3 directly to create the virtual environment that we're going to need for creating our Donkey Car instance. I'll go ahead and add a line to my bashrc file so that the environment is enabled as soon as the system boots up. I'll then activate the virtual environment, create a directory that I'll name projects, and as I did in the Mac operating system, clone the repository for the Donkey Car software. I'll check out the master branch and use pip to install all the project software. Notice that instead of using the option PC as I did before, I'll use the option Pi. With the Donkey Car software in place, I'll move to installing the machine learning library Tensorflow. You might see a few error messages, and that's due to conflicting packages between our virtual environment and the ones used by the operating system. You can check whether the installation was successful by importing the Tensorflow library into Python. Even then, you might see a few warnings, but if you follow the procedure along, things should be ready to go. I'll use the Operating System Package Manager aptitude to install the Python Opencv library. Using the same command line check as before, I'll make sure that it's correctly installed. The only conflicting package that I found when making this video was the version of the NumPy package that's included with the latest Raspbian image. To solve this, I'll install a newer version inside the virtual environment. With that done, I can use the donkey command to create a donkey car instance that I'll name Robocar Controller. Now that we have the software in place, it's time to start testing out some hardware. The first thing that I'll do is check the I2C connection to one of the boards that's controlling the motors. If the I2C address appears as shown, I can move on to modifying the configuration file. I'll specify the type of camera that I'm using, which is a simple USB webcam. Now I can run the donkey car software by using the Python command on the manage.py script with the option drive. Then on my computer, I'll open up a new tab on the web browser, navigate to the IP address of the Pi, remembering to add the port 8887. If everything goes well, I should be able to see the image from the webcam. With that check done, I'll press Ctrl+C to quit the software and move on to making the changes so that the software works with the specific hardware that I'm using to control the motors. Specifically, I'll change the actuator.py script to include a class for differential steering controlled by the board that we've connected over I2C. To make things a little bit easier, I'll copy-paste the changes from the repository I've created for this version of the donkey car. The class can be included right after the line where the donkey car module is imported. I'll then change the manage.py script so that it knows how to handle this type of drivetrain. In this case, I'll search the file for the set of if statements that are used for determining which drivetrain option was specified in the configuration file. I'll copy-paste the code as one of the options. As a sanity check, I can run the software once again and make sure that the changes haven't broken anything. In that case, I'll go ahead and turn off the Raspberry Pi, take off the connection to the stationary power supply, put the rechargeable batteries in place, and connect the internal USB cable. Once I flip the switch on, the Raspberry Pi should boot up, and after logging in again over SSH, I can run the software, refresh the browser page on my Mac, and test out the joystick controls on the right hand side of the page. If everything looks good, I can grab my phone, open up the browser and point it to the correct IP address, and drive this version of the donkey car around using the joystick interface. So there you have it. We've seen how to modify the donkey car software so that it runs with a different set of hardware from the standard that is used. I'm now ready to figure out how to make it drive autonomously, but I'll leave it for another video. If you like my videos, I invite you to my Patreon page where you can chip in a buck or two. That really helps me put in more time into the videos and release them quicker. But whatever you do, don't forget to like, subscribe, or leave me a comment. You can also interact with me on social media. I'm on Instagram, Twitter, and Facebook, and you can even use the community tab of the channel. Thank you for watching my videos, and I will see you next time.